So this is Chapter 1, Section 6, called Relations. This is for Integrated Math 1 or IM 1. So this is the homework screen that you will see this year for Mojave River Academy for alex.com, with a few exceptions because this is the teacher preview, so it doesn't give me a due date, but you will see a due date here before attempts. You always will see attempts, and for this year, you'll see the number of attempts you're on. So this is my first attempt, and you'll always have unlimited attempts. So you can come in and do this problem as many times as you would like. And this will tell you how many questions this particular assignment has. This one has 10, that's the maximum. So we'll have anywhere from 1 to 10 questions on it. Grading policy is best score, so whichever attempt is your best is the one you get to keep. And partial credit just means that, if you answer 1 out of 10 questions, you get credit for the 1 question. And always remember, once you start an assignment, you want to go down to the bottom right corner and always click that submit button. Number 1, that shows us that you've worked on it and what your grade is so far. And number 2, if you don't click that submit button, it will quite literally lock you out of every other assignment. So definitely always click that submit button. You will not see it on my screen because, again, this is a teacher account. But on your screen, once we click start here, you will see this submit assignment button at the bottom. See, I don't see it there, but you should see it on your screen. So you can see the 10 questions at the top here. On the side, there will always be these 3 tools. Every once in a while, there will also be a calculator at the top. So this is the explanation button. If I click it, it's going to tell me I'm going to lose my current question attempt because it's actually going to give me the answer to this question. So I can get the explanation for the very specific question I'm looking at. Well, it's not going to give me the answer and then tell me to come type it in. Okay, so you'll have to come back in on another attempt to try that one. If you want just a general example, you can click example, and this will give you a very similar example, but it's not going to be the exact one you're looking at. But it's very, very similar in this case. They're even using the same, locations that from what I can remember from the other screen there. So this just shows you exactly how to work out the problem. And once you're ready, you can go ahead and click close. If you want another example, you can simply click example again. It will give you another example, a completely different one. You can also message your teacher. If you do it from here, this will attach the question you're working on. So, hey, we know exactly where to help you. All right, let's go ahead and get started here. So we're going to do a little bit of review of the coordinate grid system. So this says right in order pair for the location of the park. So remember, this is our x-axis, and we can even see that. There's an x right there. And this is the y-axis going down here. Sorry, it's highlighting funny. So here's my y. So y-axis, x-axis. Remember, it always goes x, then y. And remember, the coordinate grid is just a direction system. That's all it is. I'm just telling you that you're going to go right or left or up or down. And when we're saying right or left, that's positive or negative, because if I go right, that's positive on a number line. If I go left, that's negative. If I go up, hopefully we can associate that with positive. If I go down, again, hopefully we can associate that with negative. So it's quite literally a direction system on where do I go. And first, we always identify right or left, and then we identify up or down. So if I want to go to the park, then I need to go over to the same line that this guy is on right here. So I can see I'm going to need to go over, and the starting point's always here at 0, 0, so I'm going to go over to 4. So that's going to be my first number here is 4. And then from 4, I need to go up, 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 all the way to this point here. And I can see that that's right at the 9 here. So I went up 9 units. And you can also count that. You can go 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went over 4 to the right and up 9 to get to park. All right, we will try another one here, I think. Oh, this one's going to have us actually graph this one. So this one has us look at the tools on the side here because we need to grab the little pencil in order to move around and graph this. If we graph it in the wrong spot, I can simply grab the little eraser, erase it, or I can hit the little X. So if I graph it in the wrong spot, I can always hit the X and that will just start me completely over. I can also just hit undo if I want to bring it back. So there's all kinds of tools here. So with this one, remember we have X, then Y. So it's positive 3. So that means I'm going to go to the right 3. Oop, and I accidentally tapped the screen there. That put an X. That would give me a wrong answer. So we want to be careful. Don't tap the screen there. 1, 2, 3. And then I'm going to go up 6 because it's positive 6. 1, 2, 3, 4, 5, 6. And we put a dot there. And we click check. Alrighty. So we're going to do this again. Now they're showing us the entire coordinate grid. Before they were just showing us the one quadrant. It was basically the positives quadrant, right? Because it was positive. We had the going to the right and we had going up. Now we have the entire thing here. And it wants to know the location of Dallas. So on my screen, I come down here and I locate, here's Dallas. So first I'm going to go from the middle. I'm going to say, do I go right or left? Well, I have to go right 1 to be right above Dallas. So that's a positive 1. So I'm going to type in positive 1. And then from there, I need to see how far do I move down. So go 1, 2, 3, 4, 5, 6. And I'm going down to get to 6. So it is a negative 6. So again, just a direction system. Right is positive, left is negative. That's your first number. Up is positive, down is negative. That would be your second number. All right, let's go ahead and click check here and keep moving. All right, so now we're going to graph this point. Again, they're giving us the whole coordinate system instead of just one of the quadrants. They're giving us all 4. So these are called quadrants when you go around. So we're going to go right 2 because it's a positive 2. And then we're going to go down 1, 2, 3, 4, 5, 6. So again, I should be able to see, if you can tell the crosshairs here, those lines are meant to be there to help you. So I can see that the vertical line is going right across 2. And I can see that the horizontal line here is going right across negative 6. So again, those lines are literally meant to help you make sure that you're graphing in the correct place there. All right. So now we're going to move to graphing basically kind of for a scenario. So what does it look like when we actually have some information behind the numbers that we're graphing? So each year, Dion drives 9,000 miles. Use the information to fill in the table, then plot the ordered pairs given by the table. So if he drives 9,000 miles every year, and it's been 3 years, well, we'd have 9,000 plus 9,000 plus 9,000, or 9,000 times 3. So we can kind of ignore the 1,000 part for a minute and just say, well, 9 times 3 is 27, and then I can go 1,000. So I can put the 1,000 back on after I kind of focus on just the 9 and the 3. So same thing with the 5. He went 9,000 for 5 years in a row. So we're going to multiply 9,000 times 5. So I'm going to have, let's see, 45,000. And then the last one here, we have 6 years. And again, 9,000 miles each. And so we're going to have 54,000 because, again, I'm just focusing on 6 times 9, and then I'm putting 1,000 on after. So 6 times 9 is 54, and then 1,000. All right, so we have our pieces here, and now we're going to go through and graph them. So remember, number of years, it shows us number of years on the bottom, and the distance on the for the y-axis. So we want to make sure we graph those correctly. So this is going to be our right or left. In this case, it's the number of years, so it should be right. It should be positive. And distance should also be positive. So this should be up instead of down. So we're going to go over to the right 3, and then we're going to go up to 27. And I can again see, I can use those crosshairs. I can see I'm right above 3, and I'm right in line with 27 here. So I'm going to click. The next one, I go over to 5. So I'm right above 5 now, but I need to go up a little bit more to 45,000. And I'm going to click again. The last one, I need to go over to 6. And I need to go up to 54,000. And they don't want us to connect any lines. There is no line tool to connect here. I can't draw a line with this. It won't actually let me draw anything like that if I click and try to drag. It'll just put a dot on there. So I'm going to undo that one because I don't want that there. But this is all they want to see. It's just the 3 dots on here as a plot. All right. And this does start to give us a visual. So before I move forward, we can kind of see there is a pattern here. I can definitely see this as a straight line. And if I draw all the way down, this line should start at 9,000. Well, it should actually start at 0 because he drives 0 miles in 0 years, right? If he hadn't started yet. 9,000 should actually be at the 1 because that would be every year he drives 9,000 miles. But we can definitely start to see a pattern when we put it on a visual. So it's part of the reason we like to see them this way. It's because it's much easier to interpret the data than seeing just a table of numbers sometimes. All right. So we're going to answer the questions below. So with this one, we're trying to determine dependent versus independent variables. So when we're thinking of the independent versus dependent, we want to look at which part of the scenario is dependent or needs the other one. It's affected by the other one. And which one is independent. So it is not affected by the other piece. Sorry, scooching around here for a second. So let's go ahead and read the first one just so we can kind of clarify that, I think. A function uses the input f to compute the output c, which is the independent variable for this function. So if it's an input f, I get to choose what I'm inputting there. I can choose anything I want to input for f. And then I get an output c. So c is going to be dependent on what I put in. So what the input is. So c is going to be our dependent variable at this point. So if we look at the second one, we have a family measuring its house in order. A family is measuring its house in order to figure out how much paint will be needed to paint the house, which is the dependent variable in the relationship. So if we look at the two pieces they're giving us here, size of the house or the amount of paint needed. So these are the two pieces that we have to decide whether it's dependent or independent. And we're looking specifically for the dependent variable. So if we think about the size of the house isn't going to change based on the amount of paint we need. But the amount of paint we need will change based on the size of the house. If it's a small house, we won't need as much paint as if it was a large house, right? But the amount of paint we have isn't going to change the size of the house. That's not necessarily it doesn't work out that way. So the paint is definitely dependent in this situation. And the size of the house is independent. All right. Sheen has made a table showing how the numbers of hours he spent studying for his science test influenced his scores on them. Sorry, read that funny. What is the independent variable in this relationship? So we're looking at number of hours studied versus score on a science test. So if we think about that, if I study more, I should get a better grade on a test. It should happen that way. But if I get a bad grade on the test, that doesn't take away the fact that I studied. So I can still get a bad grade on my test, and I still have the number of hours I studied. I just might have studied the wrong topics, or maybe the wrong subject, or maybe I just wasn't focused when I studied, but I still studied. So the test grade isn't going to change that. That's independent of the number of hours. But the score on the test is definitely going to be dependent on the number of hours I studied. So it's going to be influenced by that. Because as long as I'm studying the correct material, theoretically I should get a better grade. So, and we're looking for the independent variable here. So the independent variable would be the number of hours I studied. That's what I'm inputting. I get to change that. Okay. All right, let's go ahead and check that guy. And we are good to go. Okay, suppose the relation G is defined as follows. And here we have our notation for a relation. And it's just giving us the coordinates. And we want to give the domain and the range. So if you remember from class, we did go over this in the notes. Domain is another name for your x coordinates. And range is another name for your y coordinates. So it shows us how far left and right we go for domain. And it shows us how far up and down we go for range. That's what we like to look at these for. So it kind of gives us an idea of what our graph needs to look like or how big we need to make it. We do want to make sure that we write it in set notation, meaning that we're using these kind of fancy brackets. So it even says set when you go over it. So I want to click on this because I want these fancy brackets in here. And then you can click on this list if you want, so it puts more boxes in here, but you can also just click comma and it will do the same thing. It'll put another box in. So I'm going to back up one because we only have 3 points here. So if I'm looking for the x coordinates, then I have 9, -1, and -1. So 9 and a -1. I don't have to put -1 in again. When you're doing domain and range, if it's repeated, you only need to list it one time. So I can back this up and I can just have 9 and -1. For range, I'm going to do the same thing, but now I'm going to look at the y's. So now I have 1, -8, and 3. So those are all different. I do, in fact, need to list all of them just like that. So that's all we're doing. Whoop, I need to make sure I put a negative in front of that 8. And make sure I didn't leave any other negatives off. All right, perfect. So again, we're just separating them out. Here are my x coordinates, and here are my y coordinates for domain and range. All right. Oops, that's what happened. I put the negative on the 3. So that's another thing, kind of okay that happened, because I did want to bring up, it'll tell you sometimes that, okay, partial answer, you partially got this correct, and it'll sometimes give you clues to where, sometimes it doesn't, but it does let me try again. So it's not just saying, okay, well, you got it wrong, you don't get to try that one again. It's saying, okay, try this one again. Let's see if maybe you can get it right. So it does give you 3 opportunities to try out these problems, which is kind of nice. Just because you can go back and try to identify what happened there. So you're going to do the exact same thing on this one, except we're doing it from the points. So we're going to identify the domain and the range of t, because this is the relation t. That's what this graph is showing. And write your answers in set notation. So again, I want my fancy brackets here, because that's my set. And now I can go, I like to go from left to right and just go to the points that I'm running into. So if I'm looking at the x coordinates, I'm just going to go and say, what are they above or what are they below? So this is -4, comma. The next one I come to is, there's 2 of them, and that's on 2. I don't have to list it twice. I only have to list the 2 once because they're both above 2. And this last one is below 4. So there's my domain. Now for range, I'm going to do the same thing, but I'm going to go from top to bottom. So I'm looking at this one first, and I have +4, comma. This next one, this is 2. The third one here this is right up on the, where they crisscross, which is the origin, that's 0. And then if I go all the way down to this bottom one, this is right at -4. So there's my domain and my range. Again, just another name for x coordinates and another name for y coordinates. Partially, I'm simplifying that a little bit, but that's the basic idea there. All right, a couple more of these guys. Okay, so when they're giving us these ones, what we want to do is, it says, for each scenario below, choose the best graph. So we want to read the simple sentence they give us there and then think about which one represents what we're talking about. One thing that you want to make sure is that time is on the bottom quite a bit on these ones. Not always, but quite a bit. Time cannot stand still here. That would mean time froze in that spot. So we really don't pick that one when we have time. Time doesn't stop. No matter what you're doing, no matter what's happening, time continues to move forward. So we don't ever really want to pick that graph. That's kind of a trick graph. It depends on if they switch, spots here, but I've seen time on the bottom quite a lot. So this would quite literally mean time froze. It stopped moving forward. So we should always have something moving from left to right. That's what we're looking for when we're talking about time. So let's look at the sentence here. Tony walks at a constant speed to the store. So here's Tony's speed on the side. And remember, time is moving forward. If he's at a constant speed, then we want to acknowledge that. So this means Tony's speed is going down. So it's not constant. Over time, that looks like Tony is slowing down. This one doesn't make any sense because Tony's speed is going up extremely fast and time is staying still, so that's kind of odd. That one doesn't make any sense at all, like we already talked about. This one does show Tony's speed is staying the same. It's flat. That doesn't mean that he's not moving. That means that he's going the exact same speed while time is moving forward. This graph shows that Tony's speed is going faster as time moves on. So if we want a constant speed, then we want this guy here, this flat line that shows a constant speed. Sometimes that also shows like if we stopped somewhere, that we stopped moving. That's another way to look at that. So Kevin hikes away from his campsite. So here's Kevin's distance from his campsite. And again, we have time along the bottom. So we want to see that time moving forward. And then since he's going away from his campsite, that means that his distance from his campsite should be going up. So we're looking for a positive relationship here. So this one shows that it's going down. His distance from campsite is going down. That means he's going back to his campsite, if we're looking at it this way. This one doesn't make sense for time. So whenever we have time in the bottom, we just want to ignore this one. Time can't stand still. This shows that Kevin's distance from his campsite isn't changing at all. So this would be, maybe he went for a hike, but then he stopped and sat on a rock for a long time. Okay, well, his distance isn't changing. He's just sitting there. But that's not what it said. It says he hikes away from his campsite. So this one is showing that the distance is increasing as time goes on. So this is the best one here for this scenario. All right, we have one more of these guys. So it says for each scenario below, choose the graph that gives the best representation. So these ones are just getting a little bit more complicated with the story. We just need to pay attention to what they're saying. So a bird of prey leaves the nest to go hunting. So if we look on here, all of these say distance from the nest. So if it's leaving the nest to go hunting, that means the distance from the nest should be going up. So we should see some kind of positive here. That it's leaving the nest, okay? So both of these would work. This guy wouldn't work because this is a constant. The distance from the nest isn't changing. That would mean they were staying still. Same thing here. So kind of the A option and the C option, if I look at like A, B, C, D, then those two wouldn't work. So it's probably going to be this second one or the fourth one here. Or if I was going with my other reference, B or D. So now it says it flies for several minutes away from the nest before stopping to eat. So this shows that we're flying away for several minutes. Stopping means that the distance isn't changing, so this might work. This one also shows that we're flying away and maybe that we're stopping for a while. So either one of them still work at this point because they show that the bird was flying away and then it stopped for several minutes. And we're not necessarily told the scale here. So this could be several minutes or this small one could be several minutes. We don't necessarily know that part. After eating, it continues flying away from the nest for several more miles looking for food. So if we're still flying away from the nest, the distance from the nest should be growing. It should be going up still. So this guy definitely matches. The reason this one doesn't is because going down means that the distance is, he's getting closer to the nest. The distance from the nest is going back down to where we were coming back home. Didn't say we were coming back home. It said it continued to fly away. So we just need to make sure that we're paying attention to what the graph is actually telling us. All right. Eric is driving on the freeway at a constant speed. So constant means it's not changing. So when we're looking at this, the speed should not be changing. So we should have a flat line. That's a constant speed. So this is the only one that we can immediately eliminate. This is showing an increase in speed. So we're not going to use this last one. It's going to be one of the first three. We need more information now. He then speeds up to pass a truck. Okay, now we know he's going to go even faster than he was. So he was going to constant speed and he's going to go faster. So he's going to increase. This shows an increase. This one shows a decrease. So this shows that his speed is slowing down. So we know we're not going to have the second one. This one does show that he was at a constant speed and then he sped up. So it could be the first one or the second one. After passing the truck, he exits the freeway and slows down. Okay, well, this one shows that he goes back to a constant speed, so that doesn't work for the scenario. But this one shows that he's exiting the freeway and slowing down. Mainly, this just shows that he's slowing down. We don't necessarily know from the graph that he's exiting the freeway, just the fact that they told us that in the little story. But this shows constant speed, then he's sped up to pass the truck, then he's slowing down as he gets off the freeway. So let's go ahead and check that guy. And we are good to go there. So that was section 6, and I will see you in section 7.